Welcome, everyone, to our first lecture on the role of feedback in data science for policy decisions. Today, I want to take you on a journey that will illuminate how the concept of feedback, so central to the field of data science, plays an essential role in guiding effective governance and informed policymaking. As novice politicians, you are at the forefront of decision-making that affects real lives, and understanding this process can greatly enhance your ability to adapt and respond to the evolving needs of your communities. Let us begin by considering what feedback means in the context of data science. In the simplest terms, feedback is the continuous process of collecting, analyzing, and integrating new information to refine and improve models and policies. In a world where data drives decisions, feedback is the mechanism that ensures our strategies remain relevant and effective over time. Imagine, for instance, that you have deployed a new policy aimed at reducing urban traffic congestion. Initially, the policy may appear promising, but as the city evolves and citizens' behavior changes, the impact of that policy might shift. Without an effective feedback loop, your policy might become obsolete, unable to address emerging issues or capitalize on new opportunities. This is why, much like artificial intelligence models that learn and adapt from new data, our policies must also evolve in response to real-world conditions. When we examine the entire data science process, we find that feedback is not an isolated step but rather the culmination and integrative element of a 10-step methodology. To appreciate the importance of feedback, it is helpful to briefly reflect on each of these steps and consider how they collectively influence policymaking. At the outset, we start with the definition of the problem. In a political context, this involves identifying pressing public issues such as housing shortages, escalating traffic congestion, or economic disparities. A clear and well-defined problem forms the foundation upon which all subsequent efforts are built. Following the identification of the problem, the next step is data collection. For politicians, this means gathering relevant information from diverse sources, including government agencies, public surveys, social media analytics, and other digital sources. The quality and comprehensiveness of this data are crucial, as they directly influence the decisions that are made later in the process. Once the data has been collected, it must undergo cleaning. Data cleaning is the process of ensuring accuracy by removing errors, duplicates, and biases that could distort the analysis. This step is vital because even the most sophisticated analytical tools cannot compensate for flawed data. With a clean data set in hand, we move to exploratory data analysis, or EDA. This phase involves a deep dive into the data to identify trends, patterns, and correlations. In policymaking, exploratory analysis might reveal insights into how different segments of the population are affected by certain policies, or it might uncover hidden patterns that suggest alternative approaches. The insights gained during this stage lay the groundwork for feature engineering, where we select and construct key indicators that are most relevant to the policy issue at hand. For example, if you are concerned with economic development, you might focus on indicators such as unemployment rates, median income, or business growth. Once the relevant features have been identified, the next step is model selection. In the context of policy decisions, selecting a model might involve choosing a statistical or machine learning approach that can accurately predict future trends based on historical data. The chosen model is then trained using historical data, a process that involves adjusting the model parameters so that it can reliably replicate known outcomes. However, training the model is only part of the journey. It is imperative that we evaluate the model thoroughly to ensure it meets the desired accuracy and performance standards. This evaluation step is akin to testing a new law or regulation in a controlled environment before its full implementation. After the model has been rigorously evaluated, the next phase is deployment, where the refined model is integrated into the policymaking process. This could involve implementing an AI-based system for monitoring public transport, predicting economic trends, or managing city resources. Yet, even after deployment, the process does not end. It is here that feedback and iteration come into play as the final, critical step. Feedback ensures that the policy, once implemented, continues to evolve and adapt based on real-world outcomes. Without this continuous loop, the system risks stagnation, becoming less effective as circumstances change. Now that we have reviewed the full 10-step data science process, I want to emphasize how integral feedback is to the entire cycle. Feedback is not merely a final add-on, but is the dynamic force that allows policies to remain responsive and effective. In the realm of AI-driven governance, feedback mechanisms ensure that policies do not become relics of the past, but remain living documents that evolve in tandem with technological, economic, and social changes. As you consider your roles as emerging leaders, it is important to understand why you, as politicians, must be particularly attuned to the need for continuous feedback in AI-driven governance. Public opinion is not static. The needs and concerns of your constituents change with new developments, emerging technologies, and shifts in the global landscape. An effective feedback loop provides you with a mechanism to monitor these shifts and adjust your policies accordingly. For example, if a particular policy aimed at reducing traffic congestion begins to show signs of diminishing returns due to changes in population density or commuting patterns, timely feedback allows you to recalibrate your approach before the situation deteriorates further. Furthermore, technological and economic changes are relentless. Artificial intelligence models, economic forecasts, and other predictive tools rely on historical data that may not always capture sudden changes or disruptions. As a policymaker, you must recognize that these models require regular updates to remain accurate. Feedback not only identifies when a model's predictions begin to diverge from reality, but it also provides insights into why such discrepancies may be occurring. This information is invaluable, as it allows you to implement targeted interventions that address the root causes of policy failures. Ethical and social considerations also underscore the necessity for feedback. AI models, if left unchecked, can inadvertently perpetuate biases or exclude certain segments of the population. For instance, an AI system designed to allocate public resources might, without proper oversight, favor certain neighborhoods over others, leading to inequitable outcomes. Continuous feedback allows for the identification and correction of these biases. By integrating diverse data sources and actively seeking input from a wide range of stakeholders, you can ensure that your policies remain fair and just. In this way, feedback serves not only as a tool for efficiency and effectiveness, but also as a safeguard for social equity and justice. To illustrate these concepts in a tangible way, let us consider a case study involving AI in public transport optimization. Imagine a city that has decided to leverage AI to streamline its public transportation system. The initiative begins with the deployment of an AI model designed to predict peak travel times and optimize bus routes accordingly. Initially, the system appears to function as intended, with improved efficiency and reduced wait times. However, as the system operates in real time, feedback from citizens begins to reveal a significant issue. Certain areas of the city remain underserved, particularly those that were not fully accounted for in the initial data set. In response to this feedback, city officials undertake a comprehensive review of the model. They discover that while the model was effective in optimizing routes in the majority of cases, it failed to capture the unique travel patterns of residents in peripheral neighborhoods. Armed with this new information, officials work with data scientists to refine the model, incorporating additional data sources and adjusting the parameters to better account for these underserved areas. Over time, the refined AI system not only improves the overall efficiency of the public transportation network, but also ensures that all regions of the city benefit equitably from the service. This case study highlights the critical lesson that AI-driven policies are not static entities. Instead, they are iterative processes that demand continuous monitoring, evaluation, and refinement. The success of such initiatives hinges on the willingness of policymakers to embrace feedback as a central tenet of governance. By doing so, you ensure that your policies remain responsive to the needs of your constituents and adaptable to the ever-changing landscape of modern society. Throughout today's lecture, I have emphasized that feedback is not simply an afterthought in the data science process, but rather its linchpin. In every stage of the 10-step methodology, from problem definition to data collection, from cleaning to exploratory analysis, from feature engineering to model selection, training, evaluation, and deployment, the ultimate goal is to create a system that remains effective over time. Feedback and iteration serve as the critical bridge between theoretical design and practical, real-world application. Without this continuous loop of evaluation and improvement, even the most well-intentioned policies risk becoming ineffective relics that fail to address current challenges. As you reflect on these ideas, I encourage you to view feedback not as a burden or an additional task, but as an essential part of a dynamic, responsive governance strategy. In your future roles, you will face complex challenges that require not only initial insight but also ongoing adaptation. The capacity to learn from real-world data, to recognize when a strategy is no longer yielding the desired results, and to make the necessary adjustments is what distinguishes effective policymakers from those who are left behind by change. In summary, our discussion today has explored the fundamental importance of feedback in the realm of data science and governance. We began by defining feedback as the continuous process of collecting, analyzing, and integrating new data to refine models and policies. We then considered the entire 10-step process of data science, illustrating how each step contributes to a comprehensive framework for decision-making and emphasizing that the final step, feedback and iteration, is what ensures policies remain relevant. We also examined why it is critical for politicians to incorporate feedback into AI-driven governance, noting that public opinion, technological advancements, and ethical considerations all necessitate a flexible, iterative approach to policymaking. Finally, through our case study of AI in public transport optimization, we saw a real-world example of how feedback can identify shortcomings in a system and drive the necessary refinements to achieve equitable and effective outcomes. As emerging leaders, your ability to harness the power of data and feedback will be essential in crafting policies that not only address current challenges but also anticipate and adapt to future needs. Embracing a feedback-driven approach means committing to a cycle of continuous learning and improvement, an approach that will ultimately lead to more resilient, responsive, and just governance. I hope that today's lecture has provided you with a clear understanding of the pivotal role that feedback plays in data science and policy decisions, and that you leave with a renewed appreciation for the dynamic nature of effective governance. Thank you for your attention, and I look forward to exploring more aspects of data science and its applications in public policy in our future sessions.